All right, today we are moving on to the next unit. We're all the way at unit 9. Good news for those of you who like trig, we are still on trig. Now we're just moving to graphing it. So what we want to do first is really talk about the two main functions, the sine and the cosine. We're going to be honing in on those over the next few days. So before I get into the nitty-gritty, let's look over here. It's our nice unit circle. Let's think about the four angles that we know that are nice and clean and pretty in terms of coordinates. So this is, of course, 0. We have 90 degrees. Here's 180. Here's 270. And if I make it all the way back around, I'm up at 360 degrees. So the coordinate points here, of course, at 0 or 360, you move out 1. At 90, you move up 1. 180, you move back 1. And 270, you move down 1. Big thing to remember sine is the same as y, and cosine is the same as x. So when we are starting to graph the sine function, we have our x and our y-axis. So of course this is y, this is x. And it takes 360 degrees to get a full lap around. So let's make 360 degrees our last little tick mark, we'll call it. And let's go up by 90-degree intervals. So here's 90, here's 180, 270, and I can do the same in the negative direction. So we'll go a full lap around just clockwise and go up in negative 90-degree intervals. Okay, in terms of our y, because this is a sine graph, we know that the largest y value that the unit circle ever contains is going to be 1. So we'll go up to 1, and the smallest would be negative 1. So if we think about sine, why don't we start at 0 degrees, which is right at the origin. At 0 degrees, our y value is 0. Then if I move to 90, the y value or sine value is 1. At 180 degrees, the y value or sine value is back to 0. At 270, we're down at negative 1. And if we make it to 360, we're back at 0. If I went in the negative direction, negative 90 degrees has a y value or sine value of negative 1. Negative 180 has a y value or sine value of 0. Negative 270 is really up here, where the y value is 1. And a full lap around in the negative direction will get me back to a y value of 0. So this looks funky. I've got a lot of stuff going on. But this model's a nice pretty curve, or what we'll call a wave. They're kind of fun to draw. Now if you notice the pattern, big things to remember with sine, you start always at the origin. So we'll start right along this y-axis in this case, which we'll call the sinusoidal axis. It's that halfway point of the graph that divides it in half horizontally. So everything on the top matches up with the bottom for the most part, but you can see that when I go up, I come back down and hit that midline or sinusoidal axis. I go down, back to the midline, up, back to the midline, down, back to the midline. So the pattern continues, and if we extended beyond 360 degrees and instead of just making one loop, made a few more, this wave would continue. So it's a continuous function, meaning I can trace along this whole graph without ever lifting my pen. Now if we do cosine, I'll zoom out so we can see our unit circle a little bit. We're going to have the same thing. So we want our x and our y-axis drawn. Here's y, here's x, of course. A full lap around takes 360 degrees, so we'll start there and keep the scale the same. So go up by 90-degree increments, and the same in the negative direction. So here's negative 360, here's negative 180, negative 90, and negative 270. Now cosine is the same as x, and we know the furthest that x is ever going to go on the unit circle is 1 in the positive, or negative 1 on the negative. So I know this might be a little confusing because we're saying 1, negative 1 along the y, but really we're just talking what is the value of cosine. Because y equals cosine, we're really saying, well, where does y equal x, or where does this cosine graph equal 1 or negative 1? So if I start at 0, the x value at 0 degrees, right around the origin, the x value is 1, cosine is 1 there. At 90, the cosine value is 0. At 180 degrees, the x value is negative 1. 270, you're back at 0. And 360 degrees, you're back at 1. If I did the same in the negative direction, negative 90 has an x value of 0. Negative 180 has a cosine value of negative 180. Negative 270 has a cosine value of 0. And a full lap around clockwise, meaning a negative 360 degrees, will give me an x value of positive 1. So you'll see I have another curve whose pattern is super similar to the sine graph, meaning I start up high, go to the midline, down low, midline, high, midline, low, midline, high. Big thing here is cosine starts up high, so it'll start at 1 in this case. So some key vocab, our sinusoidal axis is that halfway point of the graph. We call it, I reference it or refer to it often as the midline. So it's the imaginary line that cuts that graph in half horizontally. So here, in both cases, my midline, what I keep coming back to from the highs and lows, is at y equals 0, my x-axis. Now the amplitude, all it is how far up and down I go from the midline. So if I'm looking at the sine graph, for example, the highest up I go is 1, and the furthest down I go is 1. So the distance from the midline to the upper bound and the lower bound, meaning the high and the low point, is just 1. Now the period, in this case, it just really is how long it takes to complete a full wave. So the easiest way I think about it is the distance it takes to get from the midline, high, low, back to the midline. So here, this is a full period. It's one full wave. So do you see how it took 360 degrees to get there? It'll be the same in terms of cosine. Cosine you could do, again, find the full wave. So start at the midline here, go high, midline, low, midline. So the distance between negative 90 and 270 would also be 360. You could also do it in a few different ways. Some students like to do the distance between two high points. Here it's pretty easy to see it's 360. You could also do the distance on the x-axis from two low points. Doesn't matter how you do it, but you're trying to see a full wave. So again, in the sine graph, here's a nice full wave. Here's a full wave on cosine, but these graphs look very similar. Big thing to remember, sine starts high, cosine starts low.